Type A, type B, type C. So type C is fully pressurized, and now the pressure here is not as much like your LPG, which had 17.5, but here it is about higher than 4 bar. So type C tanks are spherical or have cylindrical pressure vessel with design pressure higher than 4 bar. The cylindrical vessel can be vertically or horizontally mounted on the cradles. So this type of containment system is used for semi-pressurized or fully pressurized gas carriers. In case of semi-pressurized, they'll have a. It can also be used for fully refrigerated carriage, provided your low temperature steels are used for tank construction. And Type C basically are designed to build to for conventional pressure vessel codes. Therefore, they'll have better stress analysis. Now, the design stresses are kept low in these. There is no secondary barrier required in Type C vessel, which was required in other vessels. But here you don't have any secondary barrier. And the whole space can be filled by either IG or dry air. And for fully pressurized tankers, normal air can also be allowed. So these are your fully pressurized Type C. These are horizontal cylinders that is kept on your cradles. There is no secondary barrier requirement, and because they are already in that pressure, and this is ambient temperature. The next type of tanks, which are basically typical for LNG vessels, are membrane tanks. Now, membrane tanks are these are very thin membranes, and there are two types. One is gas transport system, and the other one is techni-gas transport system. So these are two transport systems that is associated with French company, gas and techni-gas, and their concepts are different. Gas transport, your insulation is basically the material used here is nickel alloy of 36%, which is known as INVAR. That is typical for gas transport. Nickel alloy of 36%, that is used for both primary as well as secondary barriers. Now, this alloy has got very low coefficient of thermal expansion. Therefore, you don't require any corrugation. Corrugation is required in techni-gas, which is made of stainless steel. Now, this inverse sheet membrane is very, very thin. That is 0.5 to 0.7 mm thick. So that means it is less than 1 mm thick. And therefore, it's a very light structure. And the insulation is consisting of plywood. These boxes are there, and that is filled with perlite. As I told you, perlite is the material you get in the volcanic ash. This is very light and used for insulation. Now, this is your LNG type vessel. So these are your membrane tanks. So these are non-self-supporting. So these are basically they are part of the hull. So they are non-self-supporting. So they consist of thin layer membrane supported through insulation by adjacent hull structure. The hull structure, the capacity is given. I'll just show you the other diagram. Here is the diagram. Now this is your water ballast tank here. This is the duct keel. Here also the water ballast is there. And here you have a void space. or water ballast. You can have either void space or water ballast. Then you have inter-barrier space between these two barriers. So the membrane used here is a primary barrier, which is of NVAR 0.5 to 0.7 mm thick. And then you have the insulation with perlite box, the plywood boxes filled with perlite. Then again, you have NVAR membrane, the secondary barrier, again 0.5 to 0.7 mm thick. And then again, the insulation barrier, which is plywood boxes filled with perlite. There are two barriers here. And this membrane is very, very thin. So if it is damaged, then it becomes very costly affair. If you see this, so here you will have either water ballast or void space. Here you have water ballast. Then you have this gap areas. You have this NVAR, then followed by insulation, then inter-barrier space, and then secondary barrier, and then the insulation. So these are your membrane tanks. You have walkway here. Swash bulkhead produce your FSC. These are the supports. Gas transport. Again, if you see this diagram, this is the primary barrier, 0.7 mm thick. Primary insulation box filled with perlite, 30 mm thick. In the secondary barrier, then you have inter-barrier space. Then you have a secondary barrier that is of NVAR, and then secondary insulation, then the hull. So here are your suction area, and then this is the discharge line, and this is your duct keel. These are the ballast tanks. The side passageways are here. This space can be ballast or it can be void space. That's the foot valve, that's the spray pump. Main cargo pumps are here. And then your pipelines are here. And the discharge is on top. There's a vapor dome on top. That's the membrane tanks of gas transport. Now these are the membranes, and then you have the plywood boxes filled with perlite. This is that. This is membrane, then plywood box filled with perlite, then the second, again NVAR, secondary barrier. That is membrane, 0.7. Then you have plywood box. This is the type of barriers for gas transport. Now we come to Technigas. So Technigas is not made of any alloy. This is made of stainless steel membrane system, and this will be corrugated, unlike gas transport, which was non-corrugated, because these sheets will be subject to contraction and expansion, so they'll be corrugated, and they'll be free to contract and expand independent of the adjacent sheet. So you have an inner primary barrier. Then you have a balsa insulation. Now, balsa basically is a light wood that gives an insulation. And the secondary barrier, which is like your independent type A, where you had balsa wood again. So this is your membrane tank of Technigas. So you see the tank inside, the membrane tank of Technigas, that's all corrugated. Then you might have semi-membranes, which we normally don't use nowadays. Semi-membrane is type B tank carry LNG cargo that is used in LNG carriers also. Rectangular tank consisted of plain unstiffened wall with moderately sloped and rounded edges, and the corners that are not supported so that expansion and contraction is accommodated. So the tank is 15 to 25 mm aluminum alloy. And here you have PVC insulation and a secondary barrier made of plywood 25 mm thick with PVC foam. So these days, the semi membrane type is basically obsolete now. that you don't have to study as such. So that's a recall here. You have type A, you have type B, Kevner Moss, you have type C, can be separate ones or can be merged. Then you have